So now we have example 6. Here we have just been provided with a list of numbers. We need to figure it out if it's an AP or not. So you know how we do that. You take the first term to be A1 and the following terms as A2, A3, A4 and so on. Now let's find out A2 minus A1, A3 minus A2, A4 minus A3. Let's do it together. So it's 11 minus 5, 6, 17 minus 11, 6 again, and 23 minus 17, 6. So since the difference is coming out to be the same every time, which means A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3, therefore the given list of numbers is an AP. Now if it's an AP, it will have the first term A and a common difference D. That first term A is 5 and the common difference D you have already calculated, that is 6. Now we don't know if 301 is a term of this AP or not. So let's say it is a term. So let AN, which is the nth term of this AP, be what? 301. Now what does this mean, that AN is equal to 301? Now tell me the formula for AN. Well, that's A plus n minus 1 into D, and we are equating it to 301. Now do you have the values of A and D? Yes, we do. A is 5, D is 6, so substitute them over here and you will get this. So it means that n minus 1 into 6 is equal to 301 minus 5. So that will be 296. Okay, so now when you cancel out these terms, you will ultimately get n as 151 by 3. So basically you need to open the bracket. 6n minus 6 is equal to 296. And you will get 6n as 296 plus 6, which is nothing but 302, and then you get 2 3s are 2, 151. So you get 151 by 3. Now this is the value of n, but is it possible? No, it is not possible. We reject this value of n because a term can have a value which is a fraction like 151 by 3, but a term cannot be having a position as fractional. Okay, I can say that tell me the first term of the AP, tell me the second term, seventh term, even the 1000th term, but I can't expect you to tell me say 1 by 2th term, 3 by 4th term. No, so n has to be a natural number. Okay, which clearly it is not, because natural numbers are like 1 2 3 4 5 etc, and this is a fraction. So since this is not an acceptable value of n, which means 301 is not a term of this AP. Then how many 2-digit numbers are divisible by 3? So for that we need to know what are the 2-digit numbers that we have. So they start from 10 and they go on till 99, but that is the list of all 2-digit numbers, but we want those 2-digit numbers which are divisible by 3. So 10 and 11 are not divisible by 3, so that list actually starts from 12, and then you have 15, 18 and goes on till 99. So these are actually all the 2-digit numbers which are even divisible by 3. Now we need to see if this list is an AP or not. So let me take this to be A1, this to be A2, this to be A3. Let me call this AN. Alright, so find out A2 minus A1 and A3 minus A2. So you must be getting 3. Let's see. Yeah, so since A2 minus A1 is equal to A3 minus A2 is equal to 3. Okay, so this 3 becomes D and this is actually an AP. So it's an AP with the first term A as 12 and the common difference D as 3. Now you want to find out the number of such 2-digit numbers. That means you're basically wanting to know the value of n. And this is your last term, which I'm calling AN. Okay, let's say there are n 2-digit numbers divisible by 3. So the last term would be the nth term, AN. And we know that AN is actually equal to A plus n minus 1 into D. What is my A? It's 12 plus n minus 1 into D is 3. And this is actually equal to 99. This is my nth term for this AP. So let's just open the brackets. You'll get 3n minus 3. Shift this 12 over here. So it becomes minus 12. So you have 99 minus 12, which means 3n minus 3 is equal to 87. Now take this 3 over there, you will get 3n as 87 plus 3, 90. So you get n is equal to 30. So there are 30 two-digit numbers which are divisible by 3. Then find the 11th term from the last term of the AP. So this is an AP obviously because 7 minus 10 is minus 3, 4 minus 7 is minus 3. So the difference remains the same. So this is an AP with the first term A as 10 and the common difference D as minus 3. Then we have example 8. So you have been given an AP. You can verify that it is an AP because the difference turns out to be minus 3 every time. So 7 minus 10 is minus 3. 4 minus 7 is minus 3. So this is an AP with the first term A as 10 and the common difference D as minus 3. Now you don't know how many terms are there, but you know that the last term is minus 62. So let's say that this AP is having n terms. The last term is an, that is the nth term. So if you want to find out the 11th term from the end, you first need to know how many terms are there. That's why we are interested in finding out n first and then the 11th term from the end. So how do you find it? An is already given to you as minus 62. Now what is the general formula for an? A plus n minus 1 into d, and this is equal to minus 62. We've already found out A and D, so that's 10 plus n minus 1 into minus 3 is equal to minus 62. Take this 10 on the RHS, it becomes minus, and open the brackets over here, so you get minus 3n plus 3 is equal to minus 62 minus 10, which is minus 72. Shift this 3 also over there, and you will get minus 75, minus minus cancels, and ultimately you get n is equal to 25. So this AP has a total of 25 terms. You want to find out 11th term from the end. Now don't think that it's going to be 25 minus 11, so it will be the 14th term. No, it won't be the 14th term. It will be the 15th term. So if I'm having 25 terms and I'm interested in finding out the 11th term from the end, it means I want to find out the 15th term. Now how would I represent my 15th term? As A15. And you want to find it. So we know that A15 is equal to A plus something into D. That something is 15 minus 1, so 14. You know what is A? It is 10 plus 14 into D, which is minus 3. So this is 10 minus 42. This is minus 32. So minus 32 is the answer. This is the 11th term from the end. Now just to clarify that why we are not doing 25 minus 11, is simple because if I give you say 5 terms, okay, 1, 2, 3, 4 and 5, and I tell you and I ask you that you give me the second term from the end, so you might think that it is having a total of 5 terms. The second term from the end means 5 minus 2, so it should be the third term. You will say this, but in reality when you see this, it's actually this particular term. Okay, so just don't make that error. Okay, you are not considering it like this. Okay, you don't have to perform like a subtraction over here. Okay, what you need to do is make use of logic. So it's the 15th term and not the 14th, just to clarify this, because if you get this wrong, then obviously your whole solution becomes wrong because you just don't get the right answer. You suspect the wrong term and then you get the wrong answer. Then we have example 9. So here you require little knowledge of simple interest. So we have a sum of rupees 1000, which means that is a principal P. It is invested at 8% simple interest, which means this is your rate. And per year means the duration is 1 year, time is 1 year. So let's calculate the interest at the end of each year. This does not require any AP knowledge, just simple interest knowledge. So you know that simple interest is actually equal to P into R into T upon 100. So let's find out I1. I means interest at the end of year 1. So that will be the principal, that is 1000, into the rate, which is 8%, into time 1 year divided by 100. So on solving, here you get rupees 80. To find it for the end of second year, it will be 1000 into 8, but the number of years would now become 2 upon 100. So now you will get it as rupees 160. Similarly, find I3, it will be 1000 into 8 into the number of years 3 upon 100, and on solving you will get it as rupees 240. So you can find for further terms also if you want to. So basically we want to see that this list of I1, I2, I3 and so on, okay, so is it an AP or not? So what do you need to know? So you need to know the difference over here. So just do I2 minus I1 and I3 minus I2. Now I2 minus I1 is rupees 160 minus 80, which is rupees 80. Similarly, find out I3 minus I2. It turns out to be rupees 240 minus 160, which is again rupees 80. So since I2 minus I1 is equal to I3 minus I2, therefore it is an AP. Yes, it is an AP. Okay, so here I have done nothing. Like you've been representing the terms of an AP by A1, A2, A3 so far. We're just representing them by I1, I2, I3. The meaning still remains the same. So if this is an AP, which it is, you have to find the interest at the end of 30 years. Now, if you keep on performing this process, the calculations become pretty long. So using arithmetic progression, you can find out this I30 very easily. We know that AN is equal to A plus N minus 1 into D. Making use of this formula, we can find out I30. So here N is 30. Now what is A over here? A is equal to I1 in this AP, which is rupees 80. And D is I2 minus I1 or I3 minus I2 in this AP, which is again rupees 80. So A is 80 plus N is 30. So 30 minus 1 into 80. So that turns out to be 80 plus 29 into 80. So when you solve this, you will be getting okay. So when you solve this, in the end, you will get I30 as 2400. And what is the unit? Rupees. So the interest at the end of 30 years would be rupees 2400. Moving on to example 10. So here we are having a flower bed. In the first row there are 23 rose plants, then 21, 19, so on. And in the last row you are having 5 rose plants. So how many rows are there in the flower bed? So first let's see if these rows are in AP or not. So we see this difference. So let me call this A1, A2, A3, and let's say that the number of rows are, let number of rows in flower bed be n. So this makes it my nth term an. So now let's quickly find out A2 minus A1, which is 21 minus 23 equal to minus 2. Now you tell me what is A3 minus A2? Is it also minus 2? Yes, it is, which means A2 minus A1 is turning out to be equal to A3 minus A2. So yes, it is an AP. And if it's an AP, it will have a first term A, which is 23, and the common difference D, which you've computed just now, and that is minus 2. Now you have been given AN as well, which is 5. What you need to find out is N. So make use of the fact that AN is equal to A plus N minus 1 into D. A is what? 23 plus N we don't know. So N minus 1. Refer to this, okay? D is what? Minus 2. And this entire thing is actually equal to 5 because your nth term is 5. So let's just multiply this. So we'll get minus 2n plus 2 is equal to 5 minus 23. Minus 2n is equal to 5 minus 23 minus 2. So this is minus 18 minus 2 minus 20. So my minus 2n is equal to minus 20, which means my n is equal to 10. That means how many rows are there in the flower bed? There are 10 rows, and this is your answer. Now let's study the sum of first 10 terms of an AP. So you already know how we are going to represent the first 10 terms of an AP. We have A1, A2, A3. So the nth term is AN. Now what about finding out the sum of these n terms? So you're going to basically calculate A1 plus A2 going on till AN. So instead of performing addition at every stage, I'm going to provide you with some formulas. So first let's see. Let's start with the easy ones first. So S is equal to n by 2 into A plus L. So I'm considering an AP having n terms with first term as A, common difference as D, the nth term as AN, and the last term as L. Now since this AP is anyways having n terms, so the last term L will be same as the nth term AN. So the formula is simple. S is equal to n by 2 A plus L. If you remember this, you can derive the other forms of this formula as well. That will be very easy. So S is equal to n by 2 A plus L. Now I told you L can be replaced by AN also. So I can say this is n by 2 A plus AN. So from this formula, you got this. Now you know what is AN, right? AN is, what is AN? AN is A plus n minus 1 into D. But I can club this A and A. Okay, so that will give me 2A plus n minus 1 into D. So with this, we got this, and now we got this. So just remember n by 2A plus L and you'll be able to get these formulas. But I would suggest you to learn all of them. So eventually with practice, you will get a hang of it. Now let's see exactly how are we getting this. So consider an AP having n terms. Alright, having n terms. And I told you that the general form of an AP could be like A1, A2, A3 going on till AN. Or we can also write it like A, comma A plus D, comma A plus 2D going on till A plus n minus 1 into D. This is your nth term. So for this AP, you find out the sum. The sum would be A plus D plus going on till A plus n minus 1 into D. Make this equation number 1. Then reverse the terms of the AP. This AP, just reverse its term. So reverse the terms of this AP. So now it will become A plus n minus 1 into D will come first. So A plus n minus 1 into D. Now what will be before this? So we have n. Before that comes n minus 1. And before that we have n minus 2. So here we will have A plus n minus 2 into D. Remember, we are going in reverse order, okay? And this goes on till, so the first term becomes the last term on reversal. So the last term here is A. Now for this, you can find out the sum of terms. So that will be A plus n minus 1 into D plus it will be A plus n minus 2 into D, and this addition goes on till your A. Make this equation number 2, and now you add the two equations, but the catch here is to do so term wise. What do we mean by term wise? That you add the first term to the first term, second term to the second term, last term to the last term. Okay, so we get S plus S is equal to A plus n minus 1 into D. We've added the first terms. Then let me add the second terms. So that will be A plus D plus A plus n minus 2 into D. So I've added this and this first, and this and this. Now time to add the last terms. Okay, that will be A plus n minus 1 into D plus A. So I'll just clear up the space here. So S plus S would become 2S, and on solving you will realize that every term is actually coming out to be 2A plus n minus 1 into D, 2A plus n minus 1 into D, going on like this till again 2A plus n minus 1 into D. Now we were considering n terms. So the sums that we are getting on adding the terms term wise would also be n. So I'm having n sums over here, which means I can write this n into 2A plus n minus 1 into D. Right? I need not write this factor again and again. We make use of multiplication. So for example, in junior classes you did 2 plus 2 plus 2. But then when you came in say grade 1 or 2, your teacher told you that now make use of multiplication. Simply do 2 into 4. Right? The number of times it's coming. So it's coming n times. So n into this term 2A plus n minus 1 into D. Now I can take this 2 down. So it will become S equal to n by 2 into 2A plus n minus 1 into D. So the first formula in that formula sheet, we've obtained this. What about the second formula? How do we get this? You can split this 2A into A and A. So it becomes n by 2 into a plus n minus 1 into d. So you've got that formula as well. Now this is what the general form of the nth term an. So this becomes s equal to n by 2 a plus an. So you've got this formula as well. And if it's an AP having n terms, so the last term is an. So I can write an as L. So this is nothing but s equal to n by 2 a plus L. So we are able to derive all these formulas now, and you can memorize this, and then you'll automatically get these as well. Now let's solve this example. So here you need to make use of the concept of sum of terms. So you have been given an AP. So you can verify if it's an AP or not. So 3 minus 8 is minus 5, minus 2 minus 3 is minus 5. The difference remains the same for all the terms. So that's why yes, it is an AP. Then if it's an AP, it will have a first term A, that is 8. It will have a common difference D, and that in this case we have computed as minus 5. You have to find out the sum of the first 22 terms. So basically S22 is what you have been asked to solve. So this means that your n is given to be 22. So you know A, you know D, you know n. Make use of any suitable formula from that formula sheet for sum of terms. And I believe if we are having A, n and D, then we should use Sn is equal to n by 2 into 2a plus n minus 1 into d. So we use the other two formula, n by 2 into a plus an or n by 2 into a plus l, only if we know the last term. If it's an infinite AP, anyways we don't know the last term. So then we resort to such a formula. So we have to find out S22. So n is 22, so this is 22 by 2. 2 into a, which is 8, plus n minus 1 is 21, d is minus 5. So you cancel this, this becomes 11, 2 8s are 16, and 21 minus 5, if you solve this, this will become 105. Alright, so when you solve for this, okay, 11 into 16 minus 105, then you will get 11 minus 89. And on multiplying 11 and minus 89, you will get this as minus 979. So S22 is minus 979. Then if the sum of the first 14 terms of an AP is given to you, that means S14 is 1050. And its first term, so the first term of AP A is 10, you have to find out the 20th term. So basically you need to find A20. Alright, so here making use of the formula Sn is equal to n by 2 into 2a plus n minus 1 into d. What we can do here is that we know S14, right? So let's do it for 14 terms. So S14 will be what? 14 by 2 into 2 into 10, because a is 10, plus n would be 14 again, 13d. And this S14 is what? 1050. So this becomes 7. So 7 into 20 plus 13d is equal to 1050. Let's open the brackets. You'll get 140 plus 91d is equal to 1050. That will give you 91d as 910. And on cancelling, you'll get d as 10. Now if you have a and d with you, you can easily find out a20, which will be a plus something into d. That something will be 20 minus 1. So 19. A is 10 plus 19, d is 10. That's 10 plus 190, which means that the 20th term is 200. So how we made use of this to solve the 20th term, this should be clear to you. Okay, so then we have example 13. Now this is an AP because the difference every time comes out to be minus 3. So here A is 24 and you tell me what is D? Minus 3. So how many terms do we have to take? How many means you have to tell the value of n, and the sum of those n terms is given to you as 78. So we know that Sn is equal to n by 2 into 2a plus n minus 1 into d. So here n we don't know, so n by 2 into 24 plus n minus 1 into d, which is minus 3, is equal to 78. You can take this 2 over there and multiply this here, you will get 48. Plus you will get minus 3n plus 3, and 78 into 2, if you do that, you will get 156. Now let's open the brackets. Here you will get 48n and it will give you minus 3n square, and here you will have 3n is equal to 156. So you'll have minus 3n square plus 51n. Shift this 156 on the LHS, you'll get minus 156 is equal to 0. Multiply this equation by minus 1. So you'll get 3n square minus 51n plus 156 equal to 0. So all these steps that I'm doing are in accordance with what we've studied in quadratic equation. So you first need to have the square term, then the n term, and then the constant. Now here we can even take 3 common. You'll get n square minus 17n plus 52 is equal to 0. Now I can remove this 3 and ultimately this is my quadratic equation which I need to solve. Now there are different ways to solve a quadratic equation as well, as we discussed in chapter quadratic equations. So here you can split the middle term. You can make use of factorization. So you can use minus 14n and minus 3n. So that way this will become n square minus 14n minus 3n plus 52 is equal to 0. Then here you can take n common, here you can take minus 3 common. So let me do it on a fresh page now. So then you will get, n minus 14. Then you will have plus n So when you factorize the middle term, you will get n plus 14 into n plus 3 is equal to 0. So when you factorize the middle term, you will get n minus 4 into n minus 13 as 0. Now for this entire polynomial to be 0, you know that the individual factors should be 0, which means n minus 4 is equal to 0 and n minus 13 is equal to 0. So that will give you n equal to 4 and n equal to 13. So the number of terms could be 4 or they could be 13. Then you have to find the sum of the first 1000 positive integers. So you know, in positive integers start from 1, go on like 2, 3 up to 1000 if you're asking. So it will be 1000 your last term. So here this is an AP. You have to show this. So let me take this as A1, A2, A3, and let's say this is my AN. Okay. So here now A2 minus A1 is 2 minus 1 equal to 1, and this is same as A3 minus A2, which is 1. So this is an AP. The first term A is 1 and the common difference D is also 1. The last term AN is 1000 and you want to find out its sum. So S 1000 will be equal to n by 2 into A plus AN. Why am I using this formula here? Because I know what the last term is. So this will be an easier route to solve this. So it will become 1000 upon 2 into A, which is 1, plus AN is 1000. So that is 500 into 1001, and this on solving will give you 500500. Okay, so then if I don't specify the number of integers, again you will proceed in a similar manner. So let's say I'm having first n positive integers, so it goes like this, and the last positive integer is n. So is it an AP? Yes, because here again A2 minus A1, A3 minus A2, they are all equal and they are equal to 1. You can see this difference is 1 every time. So if this is an AP, it must have some A value, some D value, right? So here A is 1, D is 1, and the last term AN is n. So again, to find Sn, you make use of the formula n by 2 into A plus AN. You don't know n, so you let it be A is 1 plus AN is n. So this is actually a very important result, that Sn is equal to nn plus 1 by 2 if you want to find out the sum of the first n positive integers. Why this result is so important is because if I ask you to sum up all the digits which fall between 1 and 10, like doing it like 1 plus 2 plus 2 going on till 10. So now in this case, it will take you some time to count. But if you make use of this formula with n equal to 10, you can directly say S10 is equal to 10 into 10 plus 1 by 2, and that is 55. Now this is still easy if you want to count it. But if I ask you to sum the integers from 1 plus 2, going on till 100, then I'm sure you are bound to get stuck somewhere. So then, in cases like these, this formula comes in very handy. And in fact, a fun fact, you can use it to trick your friends, and then you can ask them, can you sum it up quickly? And then you can show that I can do that. So yeah, so this is a very easy way of doing that. So this result is important. Okay, so find the sum of the first 24 terms, which means S24 is what you want to find out. And the nth term is given to you already as 3 plus 2n. So in questions like these, what you need to do is, like, if nth term is already given to you, you find out a1, okay, then you find out a2, you find out a3, and then you go on like till a24, because we are restricting ourselves to 24 terms, n is equal to 24. So a1 will be 3 plus 2 into 1, which makes it 5. a2 will be 3 plus 2 into 2, 4 and 3, 7. This will be 3 plus 2 into 3, and this will be 9. And a24 would be 3 plus 2 into 24, which is 3 plus 48, which is 51. So I am having a1, a2, a3 going on till a24, and they are like 5, 7, 9 going on till 51. So now find out a2 minus a1, that is 7 minus 5, 2. And if you find a3 minus a2, that is 9 minus 7, again 2. So the difference remains the same, which means it is an AP with a equal to 5 and common difference equal to 2. Now if you want to find out S24, you already know the 24th term. So you can make use of this formula, n by 2 a plus a n. Okay, so n here is 24, 24 by 2, a is 5, plus here you can have a24. So that will become 12 into 5 plus a24, which is 51. So that is 12 into 56. So when you solve this, you get S24 as 672. So this is your answer. Then we are talking about a manufacturer who produces TV sets. So let the TV sets produced be. Now this you can't verify here because all the terms won't be given to you, but this is an AP because they've said that the production increases uniformly by a fixed number. So if there is a uniform increment, it means it is an AP. So it is an AP. So let's say that we have A1, A2, A3 going on till we don't know where. And here we've been given A3 as 600 and we have been given A7 as 700. So now making use of these, what you can write is, an is actually a plus n minus 1 into d. So use that formula for A3. Okay, let's say this AP is having first term a and common difference d. So just write statements for assuming a and d. Then you can write here A3 is equal to a plus 2d. And this a plus 2d is actually equal to 600 and make this equation number 1. Similarly, you can write it for a7, that it is a plus 7 minus 1, 6d. So it is already given to you as 700, which means a plus 6d is equal to 700. Again, there are 3 ways by which you can solve this pair of linear equations in 2 variables. You can do so by elimination, substitution, cross multiplication. But I would suggest that elimination would give you the fastest results here. So let's use that. Simply do 1 minus 2. So you have a plus 2d is equal to 600. You have a plus 6d is equal to 700. On subtraction, the a term goes off and you get minus 4d is equal to 600 minus 700, which is minus 100. So basically when you cancel it all out, you get d as 25. So d is 25. And what about a? To find a, substitute this value of d in equation number 1, in this equation. So a plus 2 into 25 is equal to 600. A plus 50 is equal to 600, which means a is equal to 550. And a is nothing but the production of TV sets in the first year. So your answer would be 550 TV sets. But remember what we got as a and d, because we'll be requiring this knowledge in the other parts. So remember, A was 550 and your D was 25. They're asking for the production in the 10th here, which means A10 is questionable. So how do you get A10? Again, you can make use of the formula AN is equal to A plus N minus 1 into D. So this becomes A plus 9D. A is given to you as 550 plus 9 into D, which is 25. And when you solve this, you will get A10 as 775 TV sets. So these many TV sets are produced in the 10th year. And then you have to calculate the total production in the first 7 years. That means S7 is what you need to find. So since they've specified the number of years, that means N is given to us as 7. A we found out as 550 and D we got as 25. So we can make use of the formula Sn is equal to N by 2 into 2A plus N minus 1 into D. You can make use of that. Or again, since we know what A7 is, we know it is 700. So it will be better to use this formula A plus AN. So if you use this, N is 7 by 2 and A is 550 plus you need to find out AN here is 700. So it's 7 by 2, this will become 1250, this will become 625. And when you solve this, you will get S7 as 4375. So this is your answer. This is the total production in the first 7 years. Now is the time for a quick revision. Now let me see how much you could grasp from this chapter. So you tell me, when do I call a sequence an AP? What is so special about AP? What is the pattern here? So the pattern is that you add a fixed number every time to the preceding term and then you get the next term. Then tell me the structure of an AP. What all does an AP consist of? How do we represent the first term? By A. And what is that finite number that we keep on adding every time? What is it called? We call it common difference. How do we represent it? By D. Alright. What about the nth term or the general term? We represent it as AN. What is its formula though? A plus N minus 1 into D. Then what about this D? What value can this D have? Can it be positive? Yes. What about negative value of D or 0? Yes, both of them are possible. Okay, actually all three are possible, positive, negative, 0. Then an AP can be of two types, finite and infinite. How do we find out if it's finite or infinite? What do we look at? We look at the last term. So if the last term is present, what do we call it? Finite. And if it is not present, we call it infinite. This means it has finite number of terms. Infinite means it has infinite number of terms. Then what is the general form of an AP? A1, A2 going on till AN, where A2 minus A1 is equal to A3 minus A2 is equal to AN minus 1. Okay. Then there was another way to represent this AP. That was A plus D. Tell me what was the next term? A plus 2D. And the last term was A plus N minus 1 into D. Then we saw the sum of terms of an AP, the first 10 terms. So Sn was equal to n by 2 into A plus N. So if there are n terms, the last term would be An. So I can also write this as Sn equal to n by 2 into A plus An. And what was the expanded version of this formula? In case you don't know what the last term is, then how do you solve it? Which formula do we use? We use n by 2 into 2A plus N minus 1 into D. So that's all for this chapter. Thank you.